All right, so today we are looking at lesson 5.1, which is adding and subtracting and multiplying polynomials. Before we get into the adding, subtracting, and multiplying, we are going to look at how we classify polynomials. So first, we are looking at monomials. Mono, that means one. So really this is just one term. So a monomial is an expression that is a number, a variable, or a product of a number and or one or more variables. So for example, you could just have the number 12, and that's a monomial. You could have a variable like x, and that would be a monomial. You could have a number times a variable like 2x. You could have your variable be raised to some exponent. You could have multiple variables. So -5 times x to the fourth times y to the third. That is a monomial as well. You could have a fraction, so 1/3. These are all monomials. And the big thing with monomials is there's no adding and subtracting going on. It's just a product. It is one term. So the degree of a monomial, this is the sum of the exponents of its variables. The degree of a constant, so just the number, is going to be 0. So for example, down here, we want to find the degree of each monomial. So for that first one, 4x squared y to the 9th, it is the sum of our exponents. So the degree of a constant is 0, and then x squared and y to the 9th. So 2 plus 9, that gives me 11. -15, that is just a constant. So my degree is 0. So go ahead and take a second and find the degree of the next two. If we remember that 7x to the first, that there's that invisible 1 that we have as that exponent. So this degree is 1, and then this one will be 3. Next, we're going to look at polynomials. A polynomial is a monomial. Oops. Or the sum or difference of two or more monomials. The standard form of a polynomial means that the degrees of the monomial terms are written in order from greatest to least. So we're always going to start with the highest degree term first. So for example, polynomial written in standard form would be 3x to the fourth plus 8x to the third minus x plus 5. So you see the degrees are going down as we get further into the polynomial. So poly, that means many. So we have many terms. So we have multiple terms with polynomials. The degree of a polynomial is the degree of the monomial with the greatest exponent. So if we look back at this one, the degree of this polynomial would be 4 because that monomial has my greatest exponent of 4. So here's where we're going to classify all of our polynomials. We're going to give them names based off of the degree and based off of the number of terms. They each have a name. So starting with 7, we know because it's a constant, it has a degree of 0. When it's a degree of 0, we call that a constant. We have one term, so we know that's called a monomial. Next, we have 2x plus 5. This has a degree of 1. So this is a linear, which is what our whole last unit was about. We looked at linear equations. We call them linear because the degree is 1. The number of terms, we have 2 terms. So this is a binomial. Bi means 2. So we have 2 terms. Next, we have x squared minus 5x plus 9. This has a degree of 2. We call this a quadratic, which is what our next unit is about. We're looking at the quadratics. This has 1, 2, 3 terms. And we call this a trinomial. Next, we have x to the cube. We know that degree is 3. This is called a cubic. We have 1 term, which we know is a monomial. Next, we have x to the 4th plus 2x squared minus 1. This has a degree of 4. We could call this a quartic, but once you get to a certain point, we just start calling it 4th degree, 5th degree, so on. So we'll just call it a 4th degree. We have 3 terms, so this is a trinomial. And last, we have x to the 5th plus 7. This has a degree of 5, so this is a 5th degree. We got 2 terms, so this is a binomial. So go ahead. We want to write each of these polynomials in standard form, then name each polynomial by the degree and number of terms. So go ahead and take a second to do that. So you can check your work from those last examples on the answer key from Brightspace. We're going to move on to the next page. And we are looking at like terms, which we did at the beginning of this year. We know that like terms are terms with the same variable or variables raised to the same exponent. So we want to draw shapes around the like terms. So you want to use a different shape. So let's start with 12x. I'm going to circle it, and I'm looking for a term that also has an x with the exponent of 1. And I see 5x right here has that like term. And then I see 4x squared y. So then I'm looking for another term that has a x squared and a y. And I see one other, and that would be right here. So go ahead and find the other ones as well, the other like terms. Right, so there are like terms. 5x squared, y squared does not have a like term in this. So adding polynomials. You can add polynomials by adding like terms. So we are combining like terms. We saw this at the beginning of the year. So when we're adding, we're looking for our like terms. So 6x squared plus 2x squared, we're going to add our coefficients to each other. We want to keep it in standard form, so we want to make sure our term with the largest exponent goes first. So 6x squared plus 8x squared, 6x squared plus 2x squared is 8x squared. And then I have x minus 4x as my next two like terms. So x minus 4x gives me negative 3x. And then -1 plus 2, that's going to give me +1. So go ahead and try the other 3 examples. Again, you can check your work on those with the key on Brightspace. So now we're going to look at subtracting polynomials. You can subtract polynomials by subtracting like terms. Remember with these, we have this polynomial being subtracted from this polynomial. We have that subtraction sign, which gets distributed out to every single term. So all of these terms are going to change signs. So we have 4x squared minus 2x squared, which is 2x squared. Then we have x minus 2x. So that's going to give me negative x. And then I have -1 minus 9, same sign. So I add them, keep the sign, -10. So go ahead and try the other 3. Last, we are looking at finding perimeter. You can find the expression for the perimeter of a figure by adding the lengths of the sides, then combining like terms. So the perimeter, we are just adding the sides of our shape all together. So this has 4 sides. So I'm adding 8x minus 2 plus 17x minus 6 plus 5x plus 1 plus 9x. So then I am combining my like terms. So I have 8x plus 17x plus 5x plus 9x. Adding all of those together is going to give me 39x. And then I have -2 minus 6 plus 1. -2 minus 6, that gives me -8 plus 1 would be -7. So this is my perimeter of this figure. Go ahead and do this. Remember, these symbols mean congruent. So this side is congruent to this side, and this side is congruent to this side. So meaning that this side is the same length as this side. So this side is also 17w plus 13. Make sure to go back and check your answers with the key on Brightspace with the ones that we did not do. And go ahead and head over to part 2 to watch the multiplying polynomials.